Good morning everyone, and welcome back to our channel. Let's continue with our tutorial regarding turning. We have learned to do direct programming so we can create all the profiles we want. We feel good, we feel capable. And we start to go to our boss to tell him, you know, we can program, we can do something. Let's say we are working on Fanuc and we have learned it. The boss tells us, program that for me, but that's not a Fanuc. It's a Siemens, or an Okuma, or an ECS. What happens if the control changes? What happens is that something changes. The dialects change, as I already told you. It's a bit like how the country changes, the way of expressing oneself changes. But the concept remains the same. Adjectives, verbs, the subject, the article are needed. The concept of expression is the same. So today we only see that. We don't learn a concept, but we learn not to be afraid of anything. We must approach our work in the same way, whether we are working on a control called Pipo or on a control called Topolino. All the examples I have brought you so far were mainly made by leveraging the capabilities of Fanuc. So, a profile like this, x0, z0, always starting from the absurd point 0, programming it this way. So, x00, always starting from the absurd point 0. x20, C2 to tackle this chamfer, then go to Z20R5, insert the angle, which is made in this opening direction, so 135, and then go to Z50 because x40 remains the same. If we go to Symes, look, the concept is, this is the equation. I have done 4 controls that I know, because Adenum, for example, Fargor, I don't know them. But if tomorrow a client calls me and says there is an Adenum to program, my question is, do you have the programming manual for the Fargor? Do you have the programming manual? Of course, if I have no data, if I have no one to teach me, I must at least ask for the code. But there is a manual in a workshop. So, Fan, Siemens, Okuma, ECS, I want to do. On a Chimex, you see that the chamfer is programmed the same way. So instead of C, I used a comma. Remember that on older models, the comma is not needed as a suffix. But on the newer ones, it is required. It gives you an error. If you put the comma, it removes the error. You know, and you won't do it again. So Chimex I0Z0 goes to X20 CHR equals 2. Corresponds to CZ20 RND equals 5. This is the command for the radius. Angle 135 x40 angle at Okuma. Okuma wants to be fancy, so it wasn't enough to just put a simple code. It has 2. When I want to define a chamfer, I use fixed G75, assuming I come from G1. Otherwise, I put G1, G75. But a chamfer usually comes from a working movement. So G75 X20 L2, where L defines the chamfer, G76 defines the arc, so G76 Z20 L5A is equal to 135 X40 Z50 without putting any comma. ECS. The ECS is made by us Italians. We Italians are a bit of a pain. We know that. So we put in strange things. Exclamation point SM for the chamfer X0, Z0, X20, exclamation point SM, Z20, RA is the radius. Ra 5 seems like an error because Ra says Ra is the angle and RC is the circumference. No, it is not an error. RC instead defines the angles. So look at how they reason. They all reason in the same way, using only different ISO dialects. But the concept is more or less the same. They are photocopies of one another, where I modify this, and this. But the block is always the second. Ideally, here, I modify the R, which becomes RND, which becomes G76PL5, which becomes RA. I modify the A, which becomes ANG, which coincidentally returns to where there will be a small comma that becomes RC135. So nothing too scary. I would say that you simply need, as I already told you, not to memorize, but to understand the concept. So go to the owner and tell him, you who program on Okuma, can you give me something like a simplified guide that they give you when they sell you the machine? This is from 20 years ago, from 99, but I mean the machine is still the same as long as it refers to that machine. Of course, if they give you a FANUC manual from the 87 to work on a machine built in 2017, there's something that doesn't look right, and so we need to clarify. However, I apologize for what you will see on the screen, but let's try to modify it. So, let's put my ugly face here and take a look at this, which is the simulator. As you can see, I have entered G0, I0, Z0, G1, X20, CHR here in the simulator, and you can see that if I run the simulation, the machine simulates exactly this profile. Now let's see. We have it here, there it is. This instead is the first one. Okay, so first we have the definition of the raw piece. Don't pay attention to these things now. We are talking about programming, not particularly focusing on a CNC, so we are concerned with programming logic. Let's define the raw piece as we did in the simulator. Maybe I'll show it to you again later. We call the turret and set the spindle rotation parameters, and from here is our work. So G0, X20, C2. Here I need to set a feed rate because otherwise the simulator gives me an alarm while the whiteboard doesn't return alarms and is less of a hassle. At 135x40, Z at 50, I'm going to simulate it, and you can see that we do it in single block. The tool arrives, rests, rises, creates the chamfer, makes the angle, 135/40, Z 50. Same discussion, program check. We do it in single block. We can do it here as well. You see, I think this simulator is much clearer, but we can't read the program next to it. Obviously, that's the price to pay for having such a large video. You see, the chamfer, the angle, the 45 degrees. We are here, and also here. If I go back to edit, I still had to define the dimensions of my raw piece. This is just a graphic discussion. Once I called it, I apologize for the term. I didn't mean to be rude. I'm just a bit of a rough mechanical technician, so all this nonsense. However, they help a lot, so I didn't discriminate against anyone. The roughing tool is CNMG, so I called a tool, input the machine data, and then did exactly what I did on the FANUC, also inserting an F here, because a spindle that rotates needs an F in millimeters per minute, and I included it in this code. So changing programs, changing CNC is not a problem. Just 2 codes and away you go. The logic is always the same, as you will see later. Now, I won't be able to demonstrate it with the simulator, because the numeric simulator was designed to be used like a CAD CAM, so it doesn't have macros. However, in macros, the concept is always the same. In fact, macros are already more standardized. Thankfully, for threading, we always use G33. Be careful. We don't use G33 for threading. If someone knows programming well, we will use its specific macro, G71, which is usually used for roughing. There may be some small differences in the use of codes or plus and minus signs, but the concept remains the same. So there's nothing to fear when changing a CNC. Today, I haven't taught you anything, except a methodology for approaching work in machine shops. I hope, however, that I have reassured you by showing that in the end, one CNC is worth another. and that I have been helpful to you once again. As always, if you liked the video, a nice like and all those little things from YouTubers, sharing is always appreciated. And always make sure that these videos can also reach younger students in technical institutes or to